In this module, we're going to discuss quadratic equations. Quadratic equations are any equation that have the form x squared where the power of 2 is our highest power in the equation. So in this case, the fact that this term right here has an exponent of 2, or in the case that this term right here has a highest power of 2, makes both of these quadratic equations. Quadratic equations typically have two answers. Linear equations have one. So this exponent up here is going to tell us that there's actually two numbers that I can multiply by itself to get the number 9. Or in this case, there's two numbers I can substitute in for x in this x and this x, provide the multiplication that I need to do, add the value 2, and I should get 0. So in this case here, it's sort of easy to think about. The two numbers that multiply together to give 9 would be positive 3 and positive 3, or negative 3 and negative 3. So what we do is when we take this problem, ultimately what we're doing is we're taking the square root of both sides, because we know that the square root undoes something that's squared. So when we take the square root of this side, we get x. When we take the square root of 9, we get 3. But because the problem started as a quadratic equation, we know there's two answers, so we're just going to add that it could be plus or minus 3. I will come back to a problem that looks like this. But let's say we had another basic problem that said like x squared is equal to negative 36. So again, we're coming up with two numbers that multiply to give us negative 36. Since we're stepping into this world, this is that imaginary world, so we're going to take the square root of both sides like we did earlier. We know that there's going to be two answers. This side is going to give us x. This side is going to give us a plus or minus. And again, whenever we have that negative inside the square root, we want to break this up as negative 1 times 6 times the square root of 6. So negative 1 square root of 6 square root of 6. This becomes 6 squared. When we do that, we get I times 6 plus or minus, and that would be the answer for a problem that looks like this. When we have a quadratic equation that is in the form, what we call standard form looks like this: ax squared plus bx plus c is equal to 0, where this is a number or a coefficient, this is a number or coefficient, and this is a number or coefficient. That's called standard form. There are a couple different ways that we can solve a quadratic equation if it's given in standard form. One of the ways is through the zero product principle. One is by the square root method. And the other way that we're going to do this year is the quadratic formula. The quadratic formula works for any quadratic equation. The square root method and the zero product principle work for certain quadratics, and they are typically more efficient, so we always look to do these problems first. So let's start with an example like x squared plus 3x plus 2 is equal to 0. So we've done problems like this already. We're going to factor this like we had done in a previous course or a previous module. So in this case, we're going to think of this as x squared is going to go here, 2 is going to go here, and we're going to see if it's possible to come up with, we're going to multiply these two terms together, so that gives us 2x squared, and we're going to put this middle term down here. So we're going to see if it's possible to come up with two numbers that multiply to give us 2x squared, at the same time add to give us 3. And when we do that, we know that 2x times x multiply to give us 2x squared, but add to give us 3. So we're going to put 2x in here and x in here. Sorry about that. So in this row right here, we see that there's an x and an x. We have a 2 here. X times 2 gives us 2x. X times 1 gives us x. So this factors to be x plus 2, x plus 1. Once we have the problem in factored form, we can do what's called the zero product principle. The zero product principle says if we have numbers or factors multiplying together to give us 0, one of those factors must equal 0. So we know that either x plus 2 has to equal 0 or x plus 1 has to equal 0. So in this case, x would have to equal negative 2, and in this case, x would have to equal negative 1. And those become the two solutions to our quadratic equation. We can verify this by substituting these numbers into this equation. So for example, if I take negative 2 and I square it, and I add 3 times negative 2 plus 2, I should get 0. Well, negative 2 times negative 2 is 4. 3 times negative 2 is negative 6. Plus 2 does in fact give me 0, so this is a solution. Likewise, I could do the same thing with negative 1. So negative 1, the quantity squared, plus 3 times negative 1 plus 2 is equal to 0. Negative 1 squared is 1, minus 3 plus 2 does in fact give us 0. And those are the only two numbers in the entire world that would make this true. So for example, if I said, well, what about 1? If I take 1 squared and I do 3 times 1 plus 2 is equal to 0, I get 1 plus 3 plus 2 does not equal 0, and the number 1 is not a solution. So the idea is you're going to take your quadratic equation, factor it down to factoring, and then you're going to set each part equal to 0, and those will be your solutions. So let's try a second example. Let's try 3x squared plus 2x plus 1 is equal to 0. So again, I'm going to start by making my box. This is my 3x squared. Put my 1 down here. I multiply those two together. I get 3x squared on top. I get 2x on the bottom. I need to come up with two numbers that multiply to give me 3, that add to give me 2. Well, the only two numbers that multiply to give me 3 are 1 and 3, but they don't add to give me 2. So in this case right here, this doesn't factor. So we're not going to be able to use the zero product principle. So I know this is frustrating, but we're going to erase this part right here, and we're going to use something called the quadratic formula. You were taught the quadratic formula in a previous course, and the quadratic formula looks like this. X will equal, we're going to solve this problem, and x will equal the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So the a and the b and the c that you see in this equation, right here, here, etc., are this a, this b, and this c in standard form. So for this particular problem, we see that a is equal to 3, b is equal to 2, and c is equal to 1. And we're just going to plug these numbers, substitute these numbers in for their appropriate spaces here, and do the math behind it, and the problem will be solved. So the two answers that you're going to get here are x is equal to, we're first going to start by taking the opposite of b. So if b is equal to a positive 2, we're going to write down a negative 2. The plus or minus in this problem is how we get our two answers. Just going to start this over so that it stays on screen. So we're going to say x is equal to negative 2. The plus or minus is how we get the two answers in this problem. So one of them is negative 2 plus something, and one of them is negative 2 minus something. Then we're going to have a big long square root symbol. And under the square root symbol, we're going to take the value b and square it. So we're going to take 2 times 2, which is 4. And we're going to subtract the quantity of 4 times our value of a times our value of c. And that entire mess that we have right here will all be divided by 2 times a, which in this case is 2 times 3. So this definitely seems complicated. So we're going to start with the most complicated part that we see, which is this part right here. So you can either take your calculator and do 4 minus 4 times 3 times 1. You can do this in chunks and say this is 4 minus 12, because this part right here, when you multiply it together, gives us a 12. And 4 minus 12 would be negative 8. And if you remember from a previous assignment, we had problems that look like negative 2 plus or minus the square root of negative 8 all over 6, and we needed to simplify that. So again, we're going to focus on this part right here. The square root of negative 8 is the same as saying the square root of negative 1 times the square root of 2 times the square root of 2 times the square root of 2, because 4 times 2 is 8. So this gives us negative 2 plus or minus I from this part right here. When we combine these two square roots, we just get a 2 and then a square root of 2, all divided by 6. And like in the last assignment, since this is divisible by 2, and this is divisible by 2, and this is divisible by 2, we can take this one step farther, and we would say x is equal to negative 2 plus or minus I square root. Sorry, we're going to divide everything by 2. We're going to get negative 1 plus or minus I square root of 2 divided by 3. So I took this and divided it by 2, I took this and divided it by 2, and I took this and divided it by 2. And that would be our answer. If the book wants you to separate this out, you can think of this as two separate answers. This would be negative 1 plus I square root of 2 over 3 as one of your answers. And the second answer would be negative 1 minus I square root of 2 over 3. That is called the quadratic formula. There are numerous videos on a quadratic formula showing many more examples, and that is the process for finding the roots of a quadratic equation using the quadratic formula. Okay, so we've talked about the zero product principle. That's the one where you factor and set each part equal to 0. We talked about the quadratic formula. That's when you use the equation x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So the only thing that we haven't exactly talked about, although we did a little bit, is the square root method. So hopefully you can see that there's a big difference between these two problems right here and this problem right here. In this problem, we have an x squared term, an x term, and a constant. In this problem, we just have an x squared and some numbers. And in this one, we have something that is being squared and some numbers. If you just have an x squared or a quantity being squared and no linear term or no term that has an x, that's when we can use the square root method. So for the square root method, what we're going to do is we're just going to isolate our terms. So we're literally going to get the x squared by itself, just like we've done in the past with linear equations. So in this case, we're going to add 10 to both sides. So we get a problem this time that says x squared is equal to 15. And we're right back to the beginning of this module where we're left with an x squared term. We know that there's two answers. We're going to take the square root of this side. We're going to take the square root of this side. we can look ahead and say that 3 and 5 make 15, and neither one of those are going to break down. So in this particular case, we just get x is equal to plus or minus the square root of 15. Now in this problem over here, it's slightly more complicated, same idea. In this case, we already have this part isolated, so the only thing we need to do is take the square root of both sides. Now, when we take the square root of this side, we're left with x plus 3. When we take the square root of this side, we remember that the square root of -1 is an I, and the square root of 17 is going to stay under the radical because 17 is prime. There's nothing that breaks down 17. So we're not done here. Oops, sorry. Big key step here. Whenever I take a square root, I should get 2 answers. So I'm not done because in this case, the x is not by itself. So the last thing I need to do is subtract that 3. So I'm going to get x is equal to -3 plus or minus I square root of 17. Again, similar to the last example or a couple examples ago, if this needs to break down to two answers, your 2 answers will be -3 plus I squared of 17 and -3 minus I squared of 17. And those are your 2 solutions to this quadratic equation. So again, the key determiner, if you can use the square root method, is if you don't have something that just has x. So the difference here is that this x was inside the parenthesis, so that's different than having this. Anything in this form will either be the quadratic formula, or you should be able to break it down into factors and use the zero product principle. And that should help us with solving quadratic equations.